exercise 908, we're going to look at questions 6 to 8 now. And so question 6 says, for each of the following, complete a table of values and use it to state the graph A, B, C, or D that matches the equation. So I'll do A, and then you can do B, C, and D yourselves. So for A, we have the equation y equals x squared plus 3, and I have drawn up a table of values going from -3 to 3. So for our first x value of -3, we substitute this in. So we substitute x equals -3 in for x in our equation. So we'll have y equals, we need to make sure we put the brackets squared plus 3. So in our calculator, we go brackets -3 squared plus 3, and we get the value of 12. We then do our next one. So we go bracket -2 squared plus 3, we get the value of 7. We then go brackets -1 squared plus 3, we get 4. We then go bracket 0 squared plus 3, and we get 3. We then go bracket 1 squared plus 3, and we get 4. We then go bracket 2 squared plus 3, and we get 7. And then we go bracket 3 squared plus 3, and we get the value 12. So let's have a look at this. The first thing I'm going to look at is my x equals 0, y equals 3 point on our graphs. So if we go over to our graph, we will see that at point 0, x equals 0, y equals 3, it hits this green graph here. So I'm expecting graph B to be matched up with equation A, but I'm just going to check a couple more points, and I'm going to check points 1, 4, which it does hit, and point 2, 7, which it also hits. So that means that our equation A matches with graph B. So now you need to do the same for B, C, and D. For question 7, it says, using the results from questions 1 to 6, how can you use the equation of a parabola to tell if the parabola is concave up or concave down? So for our parabolas, when we have concave up parabolas, what we have is it's a happy smile. We're getting a V there. A happy smiley face like so. So it's concave up. When we have concave down, what we have is we have an upside down parabola, and it is like so. Let's see if it will work this time. Yeah, like so. And it's like a sad face. So concave up is happy. Oops, I thought I changed pens. Happy. And concave down is sad. That's how we can remember them. So if we have a little look at our first question, because we're told to look at questions 1 to 7 to help us with this. So question 1, our equations are y equals x squared plus 1, y equals x squared minus 1, and y equals x squared plus 2. Now all of these parabolas are concave up. If we then go to question 4, we have y equals minus x squared, y equals minus x squared plus 1, and y equals minus x squared minus 2. And all of these parabolas are concave down. So if we look back up at our concave up parabolas, the x squareds are all positive when they're concave up. Then if we look at question 4, our x squareds are all negative when they are concave down. So what that means is that if it's concave up, it's happy, but it has a positive x squared. And if it's concave down, it has a negative x squared when it's sad. Okay, so happy, when you're happy, you're positive. When you are sad, you're a bit negative and down on yourself. Question 8, we want to use a table of values ranging from -3 to 3 to graph the following equation. So I will do A, which is y equals 3 minus x squared. So what we have is our graph of y equals 3 minus x squared. Now what we should look at here is we should be able to identify by looking at an equation whether our graph is now concave up or concave down. So what we have is for our equation y equals 3 minus negative x squared, this negative is attached to our x squared. So because we have 3 minus negative x squared, this means that this graph is going to be concave down because it is sad because it's negative. So concave down. Now what we want to do is we want to substitute in our x values into our equation in order to get our y values. So our first one, x equals -3, we'll have y equals 3 minus -3 squared. When we put that into our calculator, so 3 minus bracket minus 3 squared, we get a value of -6. Now we want to put -2 into our brackets. So it'll be 3 minus -2 squared, and we get a value of -1. Now we want to put -1 into our brackets because that's our next x value. So 3 minus bracket -1 squared gives us a value of 2. Then we want to put 0 into our brackets in our calculator. So 3 minus 0 squared with brackets around it, we get the value 3. Then we put 1 where our x value goes. So 3 minus bracket 1 squared, we get the value of 2. Then we put the 2 in where the brackets are. So we have 3 minus bracket 2 squared, and we get the value of -1. And then we have 3 minus 3 squared in brackets and gets us a value of -6. Now we want to draw up our number plane, and for our number plane we want our x values to go from -3 to 3, and then we want our y values. Our smallest y value is -6, and our largest y value is 3. So we want it to go from 3 to -6, but I like to do an extra point either side as well. So now we want to plot these points. So our first point is -3, -6, which is here. Then we have -2, -1. Then we have -1, 2. We have 0, 3. We have 1, 2. We have 2, -1. And then we have 3, -6. Now we want to connect these points using a curve. So we don't want it to do a straight line. We want it to curve like so. And we want it to be smooth. Although mine isn't very smooth, you want to try and do it smooth. It will take a little bit of practice. We then want to write our equation of y equals 3 minus x squared, and we want to make sure that we have arrows as our parabola will continue on forever. Now, if we were to look at Desmos, I set this up a little bit earlier. If we were to graph it, what we have is we have our graph of y equals 3 minus x squared, which is graphed here. If I was to zoom out, you can see that our parabola goes on and on and on forever and ever and ever. So that's why we do our arrows. Then if I was to zoom in so that we get back to where we should be, yeah, here. Okay, now I'm going to put my points into Desmos to check that the points match up. So our first point was -3 minus 6. Yep. -2 minus 1. -1, 2. 0, 3. 1, 2. 2 minus 1 and 3 minus 6. So all those points lie on our parabola, so that means that we're correct. So you can either do it on Desmos and have a look and explore on Desmos, or you can draw it like so. If you do it on Desmos, take a screenshot of it and upload of your work.